Hello, everyone, and a very warm welcome to Cognito Key.
So let me ask you something. Have you ever walked up to a door and watched it just slide open, almost like it's magic? Or, how about when a police radar gun just instantly clocks a speeding car? It really does feel a bit impossible, right?
But nope, it's not magic. It's actually some really fascinating science. And you'll be surprised at just how small the secret is. Believe it or not, a lot of these modern marvels are powered by just one tiny, powerful little component. And that little hero is the Gunn Diode. Yep, it's this special kind of semiconductor that is absolutely key for creating those super high-frequency microwave signals. The exact kind of signals that make radar and motion sensors work.
All right, so what is this thing exactly? Well, a Gunn diode is what we call a transferred electronic device. And the most important thing to know about it is that it uses this really strange property called negative resistance. Now hold that thought, because we're going to dive into what that means in just a bit. But trust me, it's the real key to its power.
Now, if you're into electronics, this next part might really surprise you. See, most diodes you hear about have something called a p-n junction. But the Gunn diode? Nope, not at all. It's made from just one type of semiconductor material, N-type. That means it's packed with electrons and doesn't need any of those holes you find in p-type material. So this really unique makeup gives it a very specific structure. The best way to think about it is like a sandwich, but, instead of bread and cheese, we're talking about layers of very specially treated semiconductor material. Okay, so this sandwich has 3 layers. On the very top and the very bottom, the bread, if you will, you've got this heavily doped N-type material, which we call N+. And doped is just a fancy way of saying it's been treated to have tons of free electrons. Then, squished right in the middle is a lightly doped layer, the N- layer. And this middle part, that's the active region. That's where all the magic really happens.
So what are these layers actually made of? Well, it's not your everyday silicon, that's for sure. We're talking about some pretty exotic stuff, compound semiconductors like gallium arsenide or indium phosphide. And it's these materials that have the exact special properties needed to make the Gunn effect work. All right, so we've got this unique sandwich made of these cool, exotic materials. But how does it all come together? How does it actually work? Well, now we get to the secret sauce of the Gunn diode, that super weird-sounding negative resistance effect. It's literally what makes this thing so special. Okay, think about how electricity normally works, right? In pretty much any wire or component, when you crank up the voltage, you push more current through it. The electrons just go faster. Simple. But with a Gunn diode, oh no. After a certain point, the exact opposite happens. You give it more voltage, and the current actually goes down. The electrons literally slow down. How weird is that?
So why on earth does this happen? Well, in materials like gallium arsenide, as you apply more voltage, the electrons get so much energy that they literally jump into a different energy band. The best way to picture this is to think of them moving to a slower lane on a highway. And in this slow lane, their effective mass actually increases, which makes them way harder to move. So their mobility just drops and the total current goes down. And that, my friends, is the negative resistance effect. And it's this amazing ability to flip-flop between states so quickly that lets the Gunn diode oscillate at absolutely insane frequencies. We're talking from 10 gigahertz all the way up into the terahertz range. I mean, that is just an immense range to work with.
But, like any piece of tech, the Gunn diode isn't perfect. Of course not. It has its own specific set of pros and cons that engineers have to think about whenever they're designing a circuit with one.
So on the plus side, they're tiny, they're cheap to make, and they're super reliable at those really high frequencies. Plus, they're pretty good at ignoring noise. But on the flip side, they can be a bit sensitive to temperature changes, they do use up a good bit of power, and, well, they're not very efficient at frequencies below 10 gigahertz. Okay, so keeping those trade-offs in mind, where do we actually find these tiny little powerhouses in the real world? I think you're going to be surprised at just how common they are, just working away silently all around us. Well, for starters, they're at the very heart of military and commercial radar systems. And yep, you guessed it, they're in those automatic door sensors we talked about right at the beginning. They're also used in pedestrian safety systems, in microwave data transmitters for super fast communication, in radio systems, and even in things like tachometers that measure how fast something is spinning.
So really, the Gunn diode is just a perfect example of a tiny, almost invisible component that has this massive impact on our everyday lives. It really makes you wonder, doesn't it, what other little bits of science are out there just quietly making our modern world tick?
I really hope you enjoyed this little peek inside the tiny but mighty Gunn diode. If you found this explainer interesting, it would be awesome if you could hit that like button, maybe share it with someone you think would find it cool, and definitely subscribe to Cognito Key so you don't miss what we dive into next. Thanks so much for watching.